Okay, in this video, I modified uh, uh, an Excel file. In this Excel file, you can kind of change the various parameters on power plants. I've said before that you can boil down just about any power plant to about 7 factors, including the capacity factor, the cost per kW, the O&M cost per kW, the variable cost, the heat, the efficiency, and then the hard part really is getting the carrying charge right, and that's particularly true in the case of solar projects or hydro projects where they're so enormously capital intensive. I've said that on many occasions now. There was a project in Dubai that's changed the world, in my opinion. This project got about a 3 cent or $30 per megawatt hour. Sorry about the background noise. $30 per megawatt hour price. Now what we're going to do is make a step-down graph or step-up graph or waterfall graph, whatever you call that, to isolate and really just study what I have on this page, which is look at how screwed up I sometimes am. I'm going to the colors. Oh, what a waste. This we're going to study all the different kind of financing, including. This time I'm including degradation, I'm including different construction periods, different tax lives, different loan tenors, interest rates, whether you can sculpt together, you can put inflation in the PPA and sculpt it. What happens if you have no taxes, and have a balloon payment, which means you have no tail on the debt tenor, and all we have is a code number at the top and a series of different. We just use the index function. So if we put code number 1, we'll get the first scenario. Now to illustrate how this works, I'm going to put 0 taxes in and 0 debt in. And then we do a series of goal seeks. That's all it really does. Series of goal seeks to find carrying charge rates. And I include a first year, just take the EBITDA divided by the plant cost. And then we have a levelized cost and a real cost. Now the levelized cost, in this case I did it on purpose, where I kept hope I can get this back. Oh, we have no debt, so it's all flat. Okay, so in that case, the flat nominal LCOE would be equal to the first year rate. Now we can also measure this in a real rate, where we discount and take inflation out of the levelized cost of electricity, which I put down here. Okay, so we can get that. That one together. Okay, and now, so I'm going to put this back, and then what we have, and I have this right here, I kind of show it. This time, I just let it run from here. I just make a screenshot, we do a goal seek, use the NPV, not the IRR, with the target IRR and the goal seek, and then we put EBITDA, this EBITDA here, I hope it shows it. This has got 3 rows, so the first cell in EBITDA is the capacity charge, then the nominal, and then the real. Okay, and then we do that across different types of projects, solar, hydro, wind, thermal, because we have different degradation, different tax lives, different book lives, and different construction periods, and they all affect the carrying charge. So I try to be a little more specific on the carrying charge rate in this particular analysis, and I said, look, let's go to one of these places which has really high loans, and then gradually change the tenor, change the tail, and make it a much shorter tail, use sculpting down here, use different tax lives for the assets, and all of these things related to the book life and the degradation, well, they come from our plant type code. So our plant type code is 1. So just to restate, the goal seek goes around and just redoes a goal seek, and on each time we do the goal seek, I'll just do 1. We just set it the NPV equal to 0. That's the kind of a much better way to do the goal seek than the IRR. So that's an introduction to this. If you want to look at the goal seeks, it's really not very difficult. It's just a series of goal seeks, and we just plop the resulting levelized cost formulas into the goal seek. And finally, I should just tell you that the way the levelizing works is I just take the NPV of the revenues, and then we don't have any generation other than a degradation index, and we better keep a false right here, so it just does the discounting right to the beginning of the project life, and then we do the same discounting on the generation. That's how we get the nominal. If we get the real, we do exactly the same thing, except we just take the this is the carrying charge rate. Instead of using a nominal discount rate, we use 1 plus the nominal discount rate divided by 1 plus the inflation rate, and only apply that different discount rate in the denominator, not in the numerator. You notice the numerator is still the same old, getting the NPV of the nominal amounts at the nominal rate. Okay, and that's the LCOE. And I'm gonna give you a preview here, but when we do this, and when we start using the aggressive kind of financing, this is just a macro that does a kind of simple data table. The kind of nice thing about that is you can see what happens to the pattern of the cash flows and all that, and then you get these scenarios which we're going to graph out and isolate. Okay, so that's just I hope I kind of went through this. We did the degradation and the LCOE, we did the real LCOE, and we gave you a little bit of an introduction to the kind of the index. The next one, we're just going to explain how the scenarios